dare people interfere with my planning of crock pots. All right. Number one on the review says, if someone says in the 50-yard dash, my time is at a z-score of +2, explain to them what this might mean. So for problem number one, they said their z-score is equal to +2. So basically what that means on the normal distribution, if this was a z-score, it means that they are 2 standard deviations above the average, above the mean or something like that. Bless you. So that could be, I guess that could be good or bad depending upon how you calculate your stuff. I mean, you're 2 standard deviations above on a 50-yard dash, you're a little bit slower than a few people. Okay, number 2 says vocabulary test exists to estimate the number of words that a person has in their vocabulary. Assume that the mean number of words in an adult's vocabulary is 20,000 with a standard deviation of 40,000. Okay. That seems like an awful lot of words. I mean, I only know about 12 words that I use. All right, so they say that there's 20,000 words with a standard deviation of 4,000. So find the z-score with somebody with 14,000 words. So for A, so someone's speaking 14,000 words, how are we going to do this? We have to remember our z-score is observed minus the mean over the standard deviation. So they have 14,000 minus 20,000 over 4,000, which is 6,000 over 4,000. Get rid of all 3 of the zeros. 6 over 4. 6 over 4 is 3 over 2. So this is a z-score of, and that should have been negative. Oh my gosh, I can't believe I forgot that. Negative 1.5. All right. So is the person that speaks only 14,000 words, they are 1.5 standard deviations below the average. And then it says find the z-score of somebody who has 22,500 words. Which one are you looking at? Claire, did you get it? Good. So find the z-score of somebody with 22,500 words. So z equals 22,500 minus 20,000 over 4,000. That's a 4. So that's 2250 over 4,000. All right. Okay. I'm going to use a calculator. I can't do it in my head. Sorry, I let you all down. So 2250 divided by 4,000. So this person would have a z-score of 0.56. That's their z-score. So they're 0.56 standard deviations above the mean. And then, how do I do letter C? Z-score of negative 1.6 has a vocabulary of how many words? Any ideas? How do I do this one? I still have to use the equation, right? But how do I work it? Anybody know? Any Algebra 1 fanatics in here? Dude, I hated Algebra 1. I had you in Algebra 1. What's that? So if this is my z-score equation, and they told us that we had a z-score of negative 1.6, what should I do with this equation? There you go. So negative 1.6 is equal to observed minus 20,000 over 4,000, and then you just use a little algebra. Multiply both sides by 4,000, so negative 1.6 times 4,000 is negative 6,400 equals observed minus 20,000. I'm going to run out of room. So I'm going to add 20,000 to that. So this person with the z-score of this would speak 13,600 words in their vocabulary. So you just got to work it backwards. I know some of you were trying to forget the Algebra 1 adventure, but it came back to bite us, huh? All right. Any questions on that? Those, you feel good? All right, let's see. I got to move my paper up. Oh, that's enough of that coffee. I'm just giving you a hard time. All right, so number 3 says, assume you run an online business in which you sell clothes. The weekly sales have a mean of 1,500, standard deviation of 300. Assume that all sales are normally distributed. Make a bell curve with all 7 positions shown below. We can do that. All right, so problem number 3, it says we have a mean of this. We have standard deviation of this. So if we wanted to create ourselves our normal distribution, means in the middle. That's 1,800 because we add 300, 2,100, 2,400, and then 1,200, 900, and 600. If I did my arithmetic correctly. All right, so if we wanted to convert that to a z table, the 1,500 becomes 0, 1,800 becomes 1, 2,100 becomes 2, 2,400 becomes 3, so on and so forth. That's okay. So, so this is the one that I want to have my data in. So help me out. 34% and 34%, right? Then 13.5%. Now, friends, I'm doing this from memory, so you're going to have to help me because I'm a little slower. All right, what were these ones? I forget. 2.35, thank you. And then 0.15 over there. Cool. Thank you. 2.35. So this is just the area in those particular regions of a normal distribution. All right. So what percent of words are greater than 2,100? So for B, 2,100 and above. So I'm going to go here and this way. So 2.35 plus 0.15 is 2.5%. Or 2.50. Okay. And then the next one, let's see if we can do this. Let's change some colors on there. Ooh, purple would be fun. All right. For letter C, what is between 900 and 1,800? Okay, so we're going to go from here to here. So that means I'm going to add these together. So 34, 34, that's 68. And 68 plus 13.5. So this would be 81.5%. So can you see how that little graph would help you out if you had those all written in? And then last week your business had a z-score of +1. What was your sales? Okay, so if you were at a +1, so for D, my z-score was +1. This is my +1. This is 1 standard deviation above. So last week your business sales had a z-score of +1. What was your sales and what was your percentile that you were in? Ooh, percentile, the percent of weeks that are lower. Okay. All right, so 1,800 would have been my sales. And this is a good one to keep an eye on because we're going to see a question similar to this on the quiz tomorrow. Okay, it'll be the second part. It says, were your sales and what was your percentile of the percents before that? Okay, so we need to add these all up. So 68, so 34 and 34 is 68 plus 13.5 plus 2.35 plus 0.15. So this was 84% of your sales. We're below that. Cool. And then employees get bonuses when weekly sales are greater than 2,400. Oh, that's mean. Not average mean, just mean. This is cruel. All right, so I want to use that one. All right, so I want to talk about this one for a second because some of you will perhaps get into sales. Okay, a lot of times companies will sit there and offer an impossible goal and offer a large bonus if you can get that impossible goal. My friends, the answer to this, you have a 0.15% chance of reaching that goal in this situation. Not a 15% chance, a 0.15% chance. So you have a 99.85% chance that you won't meet that goal. But a lot of times companies will put it out there to do that, and I will tell you, it creates a situation that your salespeople for about a month or two will sit there and try and go as hard as they can, and then they're going to lag off because it becomes impossible. They're working themselves to death to try and get to that. And I mean, I kid you not, when I used to work at the car wash that I worked at, and is car wash, detail, and lube and oil, and I like selling the detail and lube and oils because that's guaranteed commission on my car washes. In order for me to get commission on the ultimate car wash, which was at the time $14.95. That they hand wash your car, they hand cleaned your wheels, then they went through the car wash, and then you got your windows and the vacuum and all that kind of stuff. And if I sold enough of those, if that was like 40% of my sales, then I got $1 for each one. And after running it, most people, if they show up every week to the car wash, they just want the cheap car wash just to have a clean car being on the cheap. So it became an impossible thing. So my detail and lube and oil sales were through the roof because they would pay me 10% on any sale I did for a detail, and they'd give me $1.50 for every lube and oil I sold. And then we had the radiator flush, which was a whole different story. But I got $6 for every one of those we did, and that usually caused more problems than anything. Because, friends, if you flush out your radiator, you want to know what happens with your radiator? No, you get nice new clean fluid put in it. It's that pretty green color fluid. You usually, when you flush out the system, if you had a small leak that was covered up because a piece of rust covered it, and then you go and flush out the system, people come back in, my radiator's leaking. And then we'd have to go through the whole ordeal to explain to them, look, it was always leaking. It was just you had a piece of rust that was in place that it got moved. You put the piece of rust back in? No. So then we had to have a whole disclaimer. People realized if we flushed the radiator, it's possible the radiator was going to leak after. So it wasn't worth selling those because the amount of headaches that came. All right. Backside, answer true, false each. A normal distribution touches the x-axis at +3 and -3. Does my normal curve touch here and here? And the answer is false. Your normal curve is an asymptote to the x-axis, so it approaches it, but it will never cross it. So that's for A. For B, says normal distribution is symmetric. True. You definitely want symmetry to it. Letter C, when the mean and the median are equal, this provides strong evidence that the data set is normally distributed. You're not going to like my answer. Partially true. Okay? The reason it's partially true is you want to fall into this category. You want to fall into this category right here with your data. You want 68% of your data to fall within 1 standard deviation. You want 95% of your data to fall within 2 standard deviations. You want 99.7% of it to fall within 3 standard deviations. If it doesn't, it's not a normal thing. So yes, you want your mean and median to be true or to be the same. Does it provide strong evidence? It's not really strong evidence. It is evidence, but there's other things that you need to also put towards knowing that'll work. Letter D, 86% of data will lie within 1 standard deviation above and 1 standard deviation below the mean. Well, 1 standard deviation above and below is 68%, and 68% is not the same thing as 86%. So letter D has to be false. It's 68%. And then that's it. Cool. We doing all right? And then let's see, the phrase check a data for normality is often used in statistics without using the word normality. Explain what this phrase means. No. Okay. Normality. So basically the mean and the median are equal. 68% of data within plus or minus 1 standard deviations. 95% of data within plus or minus 2 standard deviations. 99.7% of data. My writing is getting better and better as we go on with this day. This is only second period. So all of these are normality. So if you wanted to phrase that, and I'm not going to ask you to write that out, but those are right now all of the tests that we have to know for normality. The mean and median have to be the same. 68%, 95%, 99%, 7% fall within those standard deviations. All right. And then this also goes along with problem number 6, problem 5 and 6. I'd say that it says the same thing. So name 3 ways of checking a data for normality. The median and the mean are the same, and then the rest of it. And then I think I'm almost done. So just number 7. Is that it? Or is that number 8? All right. 7. 400 people are measured for blood glucose levels. Blood glucose average 100 milligrams per deciliter, with a standard deviation of about 20, but should be noted fluctuates throughout the day. Okay, I don't know if we really need that, but we'll go with it. And then it says 272 of the 400 measurements are within 1 standard deviation of the mean. And it says 381 of the 400 measurements are within 2 standard deviations of the mean. 399 of 400 measurements are within 2 standard deviations. I guess that should be 3 standard deviations of the mean. I made that error. This should be within 3. And then, does this provide good evidence? Well, we don't know what the median is, so that might be one thing to focus on. So for problem number 7, median, where are you? Okay, now the 272 out of 400, I want this to be equal to 68%, but if I go 272 divided by 400, oh, yes, this does work. That does work. And then 381 out of 400, I want this to be equal to 95%. So 381 divided by 400, and that's that comes to 95.25%. So I'd say this is very close. So it should be okay. Okay. And then the last one, 399 out of 400. I want this to be 99.7%. So 399 divided by 400 comes out to, the actual comes out to 99.75%. So again, that's close. I think it checks out. But my big thing that we're missing here, says 400 people are measured, blood glucose, that standard deviation. I'm missing the median. Okay, so if you were to be given this type of situation, you want to get all the information provided. If you don't, then that's where it is. So, friends, with all of this known, we will have a quiz tomorrow. Monday, Tuesday, Wednesday, I will teach the next sections. Thursday, we'll have a quiz next week as well. And I won't be here, so you guys have done that before, so it seems to work out well. Sub seems to say you guys all work together very well, which is awesome. Can I pay you guys to babysit my 7th and 8th period, though? Huh? Like a milkshake and a French fry? Sonic? Okay, tots and a milkshake.
You get mozzarella sticks.
Mozzarella sticks and a milkshake, and we're good? Cool.